Hi guys, Blogan is here again, and in this lesson I'll tell you about a new entity of the C++ language, a constant. In the previous lesson you studied your first entity, learned how to create it, write values into it, read them and use them. Today will be the same. Let's begin. A constant is a named area in memory that has a value of a specific data type, and that value can't be changed. You may notice that the definition of a constant is very similar to the definition of a variable, and they're really similar. A constant is the same as a variable, but it can only be assigned a value once, and then at the time of its creation. In other words, a constant is a variable that can be initialized only once and never change its value again. That's all the difference. Constants are allocated in memory exactly the same way as variables, because when you create a constant, you must specify a value type, give the constant a name, and initialize it with the value. Accordingly, I won't even show in a figure how constants are allocated in memory, because this figure would be similar to the one I showed for variables. So let's jump straight into the syntax for creating a constant. It begins with the keyword const followed by the usual syntax for creating a variable. You write the data type, the name of the constant, and the required value. If you don't write a value, the compiler will give you an error. By the way, in the previous lesson we made a thing such as keyword, and now you just learned a new keyword, const. When you use it, know that it applies to creating constants. It has other uses, but we won't talk about that soon. Also, don't forget that you can use unified initialization with constants, which I've listed below. Now that we've sorted out the syntax, let's try to create several constants in the code. I created several constants of different types and tried to come up with names of constants that actually exist in real life. For example, the number of days in a week is always 7, and the number of hours in a day is always 24. You may notice that constants can be used in the same way as variables. You can read their values and use them in different expressions. For example, below you can see how I display the value of a constant on the screen. Before we go further, I want to tell you one more concept, magic value. Magic value in programming is a value whose purpose the programmer may not understand. For example, imagine that I want to count the number of seconds in a year. To do this, I need to take 60, multiply by 60, then by 24, and then multiply by 365. What do all these numbers mean? The first number is the number of seconds in a minute, the second is the number of minutes in an hour, the third is the number of hours in a day, and fourth, the number of days in a year. But you might not know about it. All these values are magic. They have definitions or goals, and accordingly, they could be given a name. Magic values are generally avoided in programming because programmers must spend extra time understanding the code that uses them. How to solve this problem? Create variables or constants. Since all the numbers from this expression are constants in real life, let's create a required number of constants below. Now the whole expression is completely clear since we've given the constants clear names. Remember how in the previous lesson we talked about code naming styles? I told you that I use camel case for variables. Since we'll now also be using constants, you should know that I use uppercase for them. I think you noticed this. I advise you to also choose a specific style for your constants. Well, you're probably interested in one more important question. Why do we need constants if they are almost identical to variables and at the same time limited by the fact that their value can be changed? There are two answers, technical and architectural. Technically, there's code in C++ that won't work without constants. For example, when you create arrays, their size should be either a literal or a constant. Well, almost. Therefore, very often constants are used with arrays. From an architectural point of view, constants are designed to prevent programmers from changing the value of a variable. The fact is that programmers can sometimes write such complex code that they accidentally change the value of a variable in it, although they didn't intend to. This may lead to future problems that will be difficult to resolve. Why solve problems if you can simply prohibit the programmer from changing the value? Then, when compiling such complex expressions, the compiler will throw an error and say, "You're trying to change the value of a constant." The programmer will take a closer look at this code and correct the error. Therefore, my advice to you is that if you want to create a variable, then ask yourself the question, will you change this value after it's initialized? If not, then I advise you to make it a constant. Throughout the course, I'll create constants occasionally, so you don't forget about them. Let's summarize. A constant is a named area in memory that has its own value of a certain type, which can be changed after initialization. When you create a constant, you must give it a value. This value can be changed subsequently. Create constants when you see fit. For example, when you want to indicate the size of an array using a constant, or when you want to architecturally emphasize that this is data whose value can't be changed. And that's the end of this lesson. Thank you for watching. If you like this video, you can support me by liking this video, writing a comment under it, subscribing to the channel, donating using the link in the video description, or becoming a sponsor of my channel. All these things popularize my channel and motivate me to continue recording lessons for you. Goodbye.